Hey everybody, today we have a super short video on the sum and difference formulas. So today we're going to talk about something called sum and difference formulas, which is how we find sine and cosine and tangent of angles that are not our typical 30, 45, 60-degree angles and versions of 0, 90, 180, 270. Okay, so those are the angles that we typically are using. But what if an angle that we want to find isn't one of those common angles? So here are how we can find it. So we have three of them that we can use. The sine of some, we'll say unknown angle alpha plus or minus beta. So alpha could be any, like a 30-degree angle plus 45 is 75, or 30 minus 45 would be negative 15. Also, just to note, if I have a plus or minus right here, if I have a plus or minus there, that means whatever order I see the next one is the order of the sign that it goes with it. So sine of alpha plus beta is the sine of the alpha angle times the cosine of the beta angle plus or minus cosine of the alpha angle times the sine of the beta angle. So here's what that means. If it's sine of alpha plus beta, it's sine alpha times cosine beta plus cosine alpha sine beta. If it's sine alpha minus beta, it's sine alpha cosine beta minus cosine alpha sine beta. Okay, so I'll even put it in a different color for you so you can see what I'm talking about. So that if it's alpha minus beta, then it'll be the minus instead. Okay, so let's look at the cosine. So let's say what if I'm looking for cosine of alpha plus or minus beta? Then if it's cosine, then we say cosine of the alpha angle times the cosine of the beta angle. It's minus the sine of the alpha angle times the cosine of the beta angle. But if it was minus, then it would be plus, okay? So if it's in this order, cosine of alpha plus beta, we use cosine alpha times cosine beta minus sine alpha cosine beta. If it's cosine alpha minus beta, we use cosine alpha cosine beta plus cosine alpha cosine beta. And then lastly, actually that green is not great. We'll use purple. Tangent of alpha plus or minus beta. We're going to use tangent of alpha plus or minus tangent of beta all over 1 minus or plus tangent alpha times tangent beta. So again, what that means is if it's tangent alpha plus beta, we use tangent alpha plus tangent beta all over 1 minus tangent alpha times tangent beta. If it's tangent alpha minus beta, it's tangent alpha minus tangent beta all over 1 plus tangent alpha tangent beta. Okay, so let me give you a different color for that one. If it's the minus, we use the plus down here and the minus up here. Okay, so let's do an example together. It says, use a sum or difference formula to find the exact value of tangent 255. So we're going to use the number 255. And we're going to use one of the numbers from our list that we're really, really used to using: 30, 45, 60, 0, 90, 180, 270, and so on. So the thing about this one is the dead giveaway is that it ends in a 5. So I have to use a 45-degree angle to make up that 5. So I know 45 plus 210 would equal 255. So this is going to become my alpha and my beta. You could also switch them around and be 210 plus 45 as your alpha and beta. It doesn't matter. So I'm going to say tangent 255 is equivalent to tangent of 45 plus 210. So this is, again, my alpha and my beta. So therefore, I'm going to plug this into my tangent alpha plus beta value. So we say tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. So specifically, alpha is 45, so we'd say tangent 45 plus beta is 210, so tangent 210 all over 1 minus tangent 45 times tangent 210. So now that we've got it all written out, it's going to be helpful for me to know, okay, what is the tangent of 45? Well, if I look at my unit circle, I know the tangent of 45 is 1. And if I want to know what's the tangent of 210, remember a 210 angle is right here. It's a 30 degree. So tangent of a 30 degree angle is root 3 over 3. In the third quadrant, it's positive. So I'm going to go ahead and simplify this. I know tangent 45 is 1 plus, right, that comes from the plus. The tangent 210 is really root 3 over 3 all over 1 minus tangent 45 is 1 times tangent 210 is root 3 over 3. Well, now I'm just going to simplify this, okay? This is, and I'm going to rewrite 1. I want to make a common denominator with 3 that can be 3 over 3. So this is really 3 plus the root of 3 over 3 all over. And again, I'm going to make this a common denominator as well. 3 minus root 3 over 3. Okay. So now I can take a fraction divided by a fraction and multiply the reciprocal. So I'm going to rewrite it here. So the numerator is 3 plus the root of 3 all over 3. And I'm going to multiply. So I'm going to change this division to a multiplication, and now I'm going to do the reciprocal of our second fraction here, so 3 over 3 minus root 3. So as I multiply this, I notice these 3's cancel out. So I'm left with 3 plus root 3 all over 3 minus root 3. And that's cute. That's the answer, but there's a problem with it. I can't have a radical in the denominator. So I'm going to go ahead and multiply it by the conjugate of the denominator, which is 3 plus root 3 on top and the bottom. Whatever I do to the top, I do to the bottom. And now I have to FOIL both the numerator and the denominator. So the numerator, we're going to go 3 times 3 is 9. And then we're going to go plus 3 times root 3 and root 3 times 3. So I'm going to get plus 3 root 3 plus another 3 root 3. And then lastly, root 3 times root 3 is root 9, which is just 3. All over, we're going to FOIL this. 3 times 3 is again 9. And then the middle terms will cancel. And then negative root 3 times positive root 3 is negative 3. So if I get that on the denominator, I've got 6. 3 and 9 is 12. 3 root 3 plus 3 root 3 is 6 root 3. And if I simplify that, I get 12 over 6 is really 2. And we get plus, or not plus or minus, just plus. 6 over 6 is 1, so that's just the root of 3. So the hardest part was just simplifying those numbers down. Find the exact value of cosine 95, cosine 35 plus sine 95 and sine 35. Well, that looks familiar to me. Notice that we see a pattern of 95 and 95 and 35 and 35. So what are we really looking at is if I looked at this as, if I named this alpha and this was beta, and this was alpha and this was beta, I'm really saying I've got cosine of alpha times cosine beta plus sine alpha sine beta. So wait a minute, I've seen that before. I see that right here. So I see cosine cosine plus sine sine, and that goes to our cosine alpha minus beta. So this is really equal to cosine of alpha minus beta. Well, we just said alpha was really 95 and beta is 35. Well, cosine of 95 minus 35 is just the cosine of 60. Well, I already know the cosine of 60 is the root of 3 over 2. Oh, sorry, not root of 3 over 2. That's sine. That's 1/2. Okay, we're not doing reductions formulas, and that's it for today.